Students, today we'll discuss about the Ohm's laws and the factors on which the resistance of a conductor depends. Through Ohm's law, last day we have understood about the potential difference and the electric current that moves through a circuit and what is the relation between themselves. And we have learned that the potential difference is quite proportional to the current that flows in a circuit. So from here we can easily understand that V proportional to I. It means the potential difference V is proportional to the current or the charge in a circuit that moves. Now from here we understood again that V equal to I into R. I into R, and R we read as the constant of the resistivity. Okay, the constant of the resistance in a circuit. What is the resistance? Resistance, that is the device that helps to control the movement of the electrons through a circuit. Okay, and this is also a part of the formula. And again from here we understood about the electric current. Okay, what will be the electric current? That is I equal to VR, and it is number 2. I equal to VR means if we want to find out the current, so we have to go through the V by R, means potential difference by resistance. And here is also we can say that I equal to 1 by R into V. 1 by R into V. It means here you can observe that the relation between I and R is totally inverse. Okay, it means when the flow of current, it will move or it will pass through electricity, it will help to decrease the resistance in the wire. Okay, so it means that here the electric current is totally inverse with the resistance. So that's why resistance are always used in the circuits to control the electricity or the charges that moves through the circuit. Now we will read from here the factors on which resistance of a conductor depends. Means different factors are there on which resistance creates or show its own work. What are those creativity, or what are those steps? Number one, the factors, that is it is said that the ammeter reading is increased when a thicker wire of the same material and the same length is used in the circuit. So whenever we will go for the circuit, we have to think for the same material, same materials in wires. Okay, same materials in wires means the materials, if the wires are used of nichrome, so all the wires should be of nichrome metal. Okay, if it is use of copper, so all the wires should be made up of copper. It means the same material should be there in the wires. Number 2, same length. Okay, same length, it means in the circuit all the wires should be in same length. So here the here the formula or the resistance will work in a proper way. Next, a change in ammeter reading is observed when a wire of different materials are of the same length and the same area of cross connection is used. Okay, so for this purpose, for these two conditions, same material and same length of the wires, ammeter will show its own work in a proper way. But this work or the flowness of the electrons will be different when the next factors will come. Next factors are of the same length plus area, but it is cross connected. Okay, it is cross sectioned. For this purpose, means where when they cross sectioned or cross connected to each other, for that purpose also ammeter will show its reading in different manner. Now we observe that the resistance of the conductor depends on, means how do resistance of the conductor in a circuit depends on. Those problems or those factors are: number 1, that is the length of the wires. First of all, the length. Number 2, that is area of the weights means thickness of the weights. Area means here thickness also you can say. Okay, and number 3, on its area of the cross section. It's about the cross section. Got it? Cross section. And we have already told about the material. So all these factors are dependent on the reading through the resistance in a circuit. So first of all, the length should be equal of the weights in a circuit. Number 2, the area of the area or the thickness. Area or the thickness also dependable to follow the reading of the resistance. Number 3, cross section. Cross section helps to sometimes it helps to take the different readings. Sometimes it helps to take the same reading. And number 4, materials. The materials should be same. If the materials of the weights are different, then the reading of the resistivity or the resistance is supposed to be different. So these are the quite easy formula or easy steps or the factors you can say through which the resistance in a circuit is to change itself. Okay. So precise measurement have shown that resistance of a uniform metallic conductor is directly proportional to its length and inversely proportional to its area cross section, that is. So here from the resistance reading of the resistance in a circuit, of the function of the resistance in a circuit, we can easily say that resistance is proportional to the charges or the current. Okay, charges of the current. Here it is, okay, I'm writing here it is as L. So R proportional to L, it means that resistance in a conductor in a circuit is proportional to the charges or the charges moving through it. Okay, if the metals are the same length and the same material and the same thickness. Got it? When these three factors will be same, for that purpose resistance in a conductor will be as same or as equal to the charges that flows or the electrons flows in the conductors in the circuit. Got it? And it will different when it will come as a cross section. When it will come as a cross section, for that purpose, based on the area, it will said as the R proportional to 1 by A. R proportional to 1 by A. Area of the cross section, when it will be said or it will be functioned in a circuit, for that purpose the resistance of the circuit will be inverse proportional with the area of the cross section. Okay, according to the area of the cross section, obviously the resistance will be of its inverse proportional. Got it? So from here, two formula again we have got, that is 3 and that is 4. R proportional to L when same length, same area and same materials are used in a circuit, and when the cross section of the materials are told, for that purpose the area of the cross section of the weights will be of the inverse proportional to the resistance. Okay, so that's why R proportional to L and R proportional to 1 by A. Now if we want to take out this proportional, so R proportional to 1 by A we have told, right? But if we take out the proportional, then R equal to 1 by A, so of course a constant will come. The constant is said as a rho. This constant is named as rho. Okay, rho. This rho is used for this resistance purpose, and this rho is called the constant of the proportionality. Got it? Constant of the proportionality, and is called the electrical resistivity of the materials of the conductor. Got it? And its what is its SI units? SI unit is ohm meter. Ohm meter is the SI unit of the rho. Now we will go for few of the conductors, then insulators and the alloys metals. Okay, conductors means they have the conductivity through for passing the electrons, and we have already read that whenever the charges of the electrons it moves, it always gone through the inverse proportional with the resistance. It means from here we can say the good conductors or the metals, those which have the ability to pass the electrons in a very faster way and maximum amount of electrons, those have the those have very less amount of the resistance. Okay, so from here we can easily say that conductors have less resistance. Conductors have less resistance. Okay, what is its? And if we go for the alloys, alloys are also made up of different materials. So, and you will observe that in different devices it is used. Got it? Because it's a metallic substance and it is totally combined substances of different metals, those which have the good conductivity into itself. Okay, just we can say that tungsten. Okay, tungsten is a very important, very popular name. Tungsten, that is also a kind of alloy, and it is used for making the filament in the bulb. Got it? So it means they are the good conductors. These both are the good conductors. For the conductors, we can say easily that the nichrome ware, then the copper ware. Okay, they are also good conductors. So here the good conductors as well as the tungsten as alloy, and the conductors as the copper and nichrome wares, although have, as they are good conductors, it means they also have the poor resistance into itself. Now if we go for what is the race of its, the race will be 10 to the power minus 8 and it's less, 10 to the power minus 8 and it's less. Okay, now if we go for the insulators, insulators have the we know that insulators are the quite poor conductivity, they have the poor conductivity through the of the electrons, means they are totally poor to pass the electrons into itself, so that's why they have the high resistance. Okay, it goes 10 to the power 12 to more. Okay, different insulators have the different properties to take or to show its own resistivity. Got it? So that's why it always goes in a positive manner and it takes the maximum amount of the resistance into itself. That's why it burns. But as conductors have the less resistance, so it doesn't burn, it helps to pass the electricity into itself. Okay, so it is all about this. Now the table is given in your book. From there you will read the different materials name and their resistivity. It is no need to memorize, but you have to practice because it will come through different type of numerical portions. Okay, in different maths it comes based on metals, insulators, so there you have to put this resistivity. So it is all about the resistance and the factors of the resistance based on different conductors. Okay, that's all.